This is the sun, our star. We are alive only because of it. And without its light and warmth, Earth would be nothing more than a frozen rock drifting through the darkness of space. And yet this same star that gives us life carries within it the power to destroy us. The sun is a G-type main sequence star, about 4.6 billion years old, already halfway through its 10 billion year lifetime, meaning it is a middle-aged star, and it sits at an average distance of 150 million kilometers from Earth, a distance known as 1 astronomical unit. Its diameter is about 1.39 million kilometers, making it 109 times wider than Earth and about 10 times wider than Jupiter, containing 99.86% of all the mass in the solar system. It is composed of about 74% hydrogen, 24% helium, and about 2% heavier elements such as oxygen, carbon, neon, and iron, which makes it a population 1 star, the youngest and metal-rich type of star in our galaxy. The sun is layered like an onion. Deep inside lies the core, where nuclear fusion occurs, crushing hydrogen atoms into helium at 15 million degrees Celsius. Surrounding it is the radiative zone, where photons created in the core take over 100,000 years to slowly crawl outward through radiation. Above that is the convective zone, where energy finally moves through rising and falling currents of plasma. Then comes the photosphere, the visible surface of the sun that glows at 5,500 degrees Celsius. Higher still is the chromosphere, a reddish layer seen during solar eclipses. And beyond it stretches the corona, the sun's outer atmosphere, a ghostly crown of plasma reaching millions of degrees Celsius and blasting a constant stream of solar wind into space. Strangely, the corona blazes far hotter than the sun's surface, a mystery that continues to puzzle scientists. Solar wind, a flow of charged particles moving outward in all directions, shapes Earth's magnetosphere, forming a protective shield that deflects deadly cosmic rays from deep space and causes breathtaking auroras when it collides with our atmosphere. The sun is wrapped in a vast, invisible magnetic field that twists, tangles, and sometimes flips entirely every 11 years, driving sunspots, solar flares, and coronal mass ejections in a cosmic dance of energy. The sun's surface is not uniform. Dark patches known as sunspots, caused by twisted magnetic fields, mark cooler regions, and the number of these sunspots rises and falls in an 11-year solar cycle, along with increases in solar flares and coronal mass ejections that can disrupt satellites, GPS, power grids, radio communications, and even influence Earth's climate. Within, sometimes the sun erupts with solar flares so gigantic that they stretch across distances equal to 9 Earths, releasing energy equivalent to billions of nuclear bombs. Deep in the core, nuclear fusion also produces tiny particles called neutrinos. Every second, billions of these neutrinos pass through your body unnoticed, carrying a direct message from the heart of our star. Scientists study the sun's interior using helioseismology, listening to its natural sound waves to map its structure and predict its behavior, like seismology for the cosmos. The sun's energy output is staggering. Every second, it radiates about 3.8 times 10 to the 26th watts of power, enough to supply Earth's total energy needs for millions of years if we could capture it all. Its gravitational pull is the glue that holds the solar system together, a force 28 times stronger than Earth's surface gravity, binding planets, comets, and asteroids in orbit around it. Despite appearing yellow to us on Earth due to our atmosphere, the sun is actually white in space, emitting nearly equal amounts of all visible wavelengths of light. It also emits ultraviolet rays, X-rays, and other forms of radiation, which shape Earth's atmosphere and drive space weather. The sun itself is not fixed. It is orbiting the center of the Milky Way galaxy at about 828,000 kilometers per hour, taking 225 to 250 million years to complete just one orbit. Light, the fastest thing in the universe, takes about 8 minutes and 20 seconds to travel from the sun to Earth, which means every time you look at the sun, you are actually seeing it as it was 8 minutes ago. For millennia, humans have revered the sun. Ancient Egyptians worshipped Ra, the sun god, while countless civilizations recognized its life-giving power, weaving it into myths, calendars, and rituals. To study this star up close, NASA launched the Parker Solar Probe in 2018, the fastest spacecraft ever built, reaching speeds of about 700,000 kilometers per hour and flying as close as 6.16 million kilometers from the Sun, even closer than Mercury's orbit. It survives these deadly conditions with a carbon composite shield made of carbon-carbon foam and ceramic coating, allowing it to endure temperatures of about 1,370 degrees Celsius while keeping its instruments safe at room temperature. The Sun was born 4.6 billion years ago from a giant collapsing cloud of gas and dust called a nebula, and since then it has been in its stable main sequence phase, fusing hydrogen into helium. In about 5 billion years, it will run out of hydrogen fuel in its core, swell into a monstrous red giant star so large that it will swallow Mercury, Venus, and possibly Earth, then shed its outer layers into a glowing planetary nebula before shrinking down into a dense white dwarf, which will gradually cool and fade over trillions of years until it becomes a black dwarf, a dead star remnant. From 2025, the Sun has roughly 5 billion years of life left, but its fiery death is inevitable, and when it comes, no planet in the solar system will escape its fury. Every sunrise we see today is a reminder of the unimaginable power of our star, a cosmic engine burning without oxygen through nuclear fusion, a star that gives us life and light, yet carries within it the promise of a violent and inevitable end, making the Sun both our eternal guardian and our ultimate destiny. Now, if this cosmic powerhouse didn't blow your mind, I don't know what will. Hit that subscribe button faster than a photon escaping the Sun, because missing out would be more dangerous than standing in a solar flare. And don't worry, I promise I won't make you do the Sun's core homework. Subscribe and join our cosmic adventure.